Question number 64 has the integral of 2x plus 1 over 4 plus x squared dx. Now, in this case here, we could think of substitution because the derivative of 4 plus 2x squared would be 2x, which I've highlighted in red. However, that plus 1 makes it a bit of a problem. What we need to recognize for this one is that we can actually split up the 2x and the plus 1. And the plus 1 will conveniently group with the denominator, and that denominator happens to be an inverse trig. So it's going to look like this. We're going to split it up into 2x over 4 plus x squared. Now this can be done with substitution, and then we end up with plus 1 over 4 plus x squared dx, and this one could be done with arctan. So, and I'm just going to color code these here. There's my substitution, and this one is going to be my arctan. So for the substitution, we're going to let u equal 4 plus x squared, which makes my du 2x dx. And that is perfect because that is exactly what I want for my du. And then I can do my substitution. I have the integral of 1 over u du, and that can be ln. So we're going to integrate this to log of u plus c. I'm going to put the plus c at the end, so I'll just make that log u, and then we can substitute back in our 4 plus x squared. Okay, so then we have plus. In this case, this integral on the right is just arctan, so we end up with plus. That just becomes arctan of x. It's going to be arctan of x. We have the extra coefficient of 2 squared here, so maybe I'm going to write that out. So we end up with the arctan of 1 over 2 squared plus x squared dx. So when I do the arctan, I'm going to end up with 1 over 2 arctan of x over 2. And then we have the plus c, and that's our answer. So looking at the solutions, we can see that it looks like D is the correct answer. So D represents the solution that we came up with. Okay, so log of x squared plus 4, they don't have the absolute value because x squared plus 4 is always positive. And then we have 1/2 arctan of x over 2.